Welcome, boys and girls. Today we're going to talk about forces and interactions. And to help us learn, let's bring in a new friend, Wendy the Wolf. Hi, Wendy.
Hi, friends. How are you? Ready to learn about forces? A force can be described as a push or a pull that changes the motion of an object, causing it to speed up or slow down. So, when you hammer a nail, you apply a force to the nail. And when you throw hot dogs to feed your pet alligator, you apply force on the hot dogs. Forces are always applied in a particular direction. So, if for some strange reason you decide to pull a cart full of hungry piranha, you are applying force in this direction. But if you decided instead to push the cart while prancing along, you are exerting force in the opposite direction. Forces can be large or small. You can hit a ball with a lot of force to make it go further. Or you can hit a ball with very little force and it doesn't go far at all. An object can have many forces acting on it at the same time. If a large force is applied on one side, but a small force is applied on the other side, the forces are unbalanced and the motion of the object changes. But if the same amount of force is applied from each side, the forces cancel out and are called balanced, and the object's motion does not change. So a standing object remains standing and doesn't move. Oh, I think I hear my pack calling. Be back later.
Thanks, Wendy. Now, there's a special interaction that is always pulling us down to Earth. Do you know what it is? It's gravity. While gravity is not technically a force, in most cases it behaves like a force, and so we can think of it in the same way. When a roller coaster is at the top of its track, it comes down because of gravity. If you throw a banana in the air, it comes back down, again because of gravity. Knowing how gravity works can sometimes help us predict how an object will move. Let's look at a marble rolling in a bowl. When the marble is at the top, gravity pulls it down and so it rolls to the bottom. The marble's momentum keeps it rolling to the top of the other side until gravity pulls the marble down again. And by observing its motion, you can predict where the marble will go next based on where it is in the bowl. A ham tied to a rope behaves similarly. You can tell where the ham will go based on how it was moving earlier. Okay, now do you think that objects must touch each other to exert force? The answer is no. And to tell us more about non-contact interactions, let's bring back Wendy the Wolf. Welcome back.
Hi again, friends. Now that I'm done with my chores, let's talk about two special interactions, electric and magnetic, which can exert force without any contact. To learn about electric interactions, let's use some party balloons. If you took a balloon and tried to stick it to me without any glue or tape, it would just fall off, right? But what if you take the balloon and rub it on my fur first? Now, when you bring it close to me, the balloon makes my fur stand up without even touching it. So what's happening here? Well, rubbing the balloon on my fur produces an interaction called static electricity. The balloon and my fur have an opposite charge, so the interaction acts to bring them together, which is what raises my fur towards the balloon. If you rub a second balloon on my fur and hold it against the first, the two balloons move apart. Both balloons have the same charge, which creates a repelling force that pushes them away from each other. Magnets work the same way. Each magnet has two sides, and these sides are called the North Pole and the South Pole. If you take two magnets and point the same poles towards each other, the magnets push each other away. But if you point the North Pole of one magnet to the South Pole of the other magnet, the magnets attract each other. Magnetic forces stack up, so two magnets are stronger than one. Is that a ham on a rope over there? Snack time.
Bye, Wendy. Have a nice snack. Okay, just a couple more things. Magnetic and electric force depends on the distance between the two objects. So if you put a magnet close to a paper clip, the force is big and the clip sticks to the magnet. If the magnet is far away, the force is small and the clip doesn't move. And remember that even though we think of force as something that requires contact, magnetic and electric forces work without any contact at all. And now you know all about forces and interactions. Thanks for watching.